For part one of the chapter review, they're going to ask us to find limits of things. Now let's remember that we have only pretty much found limits, used conjugates, and played with derivatives in this particular chapter. So for today, I'm guessing we're going to be using all of those things. Let's start with the first one. E to the x cubed minus x. As x approaches 1, they want us to find the limit. Well, the first thing you can do is plug 1 in. So that would be e to the 1 cubed minus 1, which would be e to the 0. And e to the 0, like anything else, is equal to 1. So that's going to be the answer for the first one. It doesn't get easier than that, and we're about to prove it because some of these questions look like they're going to be quite a bit harder. Let's fill this in here. Okay. Next one, limit as x approaches negative 3 of x squared minus 9 over x squared plus 2x minus 3. This looks like a factor, and because we definitely played with conjugates, let's come out here and we'll rewrite this as, remember, a squared minus b squared comes from a plus b times a minus b. So if I want to use that here, no problemo, right? We just need to write it as x plus 3, x minus 3, over, what's the bottom going to factor out to be? That looks like we have a plus 2 here, so it looks like it's going to be an x plus 3 and an x minus 1. These add up to positive 2, and they multiply to make negative 3, so that looks correct. You can imagine just crossing this out, and we're going to get x minus 3 over x minus 1. And whereas originally plugging negative 3 into this, you would get 0 divided by 0, which is meaningless. It doesn't mean 0. It means that we don't know. It means indeterminate. It means naughty, naughty. This will give us negative 6 over negative 3 minus 1 would be negative 4. So our answer is going to be 3/2. So whatever the graph does, eventually it's going to approach 3/2 for its value. Cool. This is exactly how you want to try and work with limit. Okay, next. This one looks harder. Limit as h approaches 0. H minus 1 cubed plus 1 over h. Obviously, we're going to have a divide by 0, and it's going to be negative 1 plus 1, so we will get 0 divided by 0 again. That's the indeterminate form. It means we don't know. So we have to do some play. And I would like to write it as h minus 1 cubed. What do you think? Should we expand it? Let's just expand it. That would be h cubed plus 3h squared times 1, negative 1, because that's our other value, plus 3h times negative 1 squared, and then it would be negative 1 cubed, wouldn't it? And then we have a plus 1, all that divided by h. So let's see what we've got. This is a negative 1 and a positive 1. That's out. So what I'm going to see here is h cubed minus 3h squared plus 3h, all divided by h here. So let's cancel one of these out of each. And we get h squared minus 3h plus 3 as h approaches 0. So this is 0, this is 0. So I think 3 is going to be our answer. I think 3 is going to be our answer. You might want to double check me on that. It's up to you to make sure, but that seems right to me. Next one. Limit as r approaches 9. Square root of r over r minus 9 to the 4th. This one seems ugly. Let's try plugging it in. We would get 3 on the bottom, or on the top, excuse me, and we would get 0 on the bottom. Well, this is infinity, right? And moreover, the square root of r could also be -3. So it's either infinity or negative infinity. Either way, it doesn't matter to us because we only need to say that the limit does not exist. They didn't say to find which version of not existing it is. We could play around with the graph all day, but it doesn't matter. It doesn't exist. That was easy. Next one, limit as u approaches 1. Here's u to the 4th. That's scary. -1 over u cubed plus 5u squared minus 6u. I think you can see right away if you do 1 plus 5 minus 6, you're going to get a divide by 0, and a 1 minus 1, you're going to get a 0. So again, we have the indeterminate form. Not an accident, I'm sure of that. Indeterminate form. So we're going to have to do something. And we only know how to find derivatives and conjugates in this chapter, so I'm thinking we're going to be doing conjugates. And remember, a plus b times a minus b gives us a squared minus b squared with no middle term, right? Well, what's on top here, right? Let's do it that way. Let's just see if it works. I'm going to say u squared minus 1 times u squared plus 1 over that malarkey, u cubed plus 5u squared minus 6u. You know what else? I can definitely factor this one the same way. We can do a conjugate again. So we could do u plus 1, u minus 1, and then we have that other term, u squared plus 1, that we don't know how to factor without complex numbers. I can take a u out of the bottom, so we get like u squared plus 5u minus 6. And look, I can factor the bottom now too. U plus 1, u minus 1, u squared plus 1 over u times, and that's something that adds up to positive 5 and multiplies to -6. That's definitely u plus 6 and u minus 1. You can see where I'm going with this. We'll cancel this out. So we see u plus 1 over u times u plus 6. Let's see if this gives us an indeterminate form if we have to do more. So let's plug in 1 for our value. 1 plus 1 is 2. 1 times 1 plus 6 is 7. So 2/7 is going to be our limit here as u approaches 1. So you see how algebraic malarkey, I don't know a better word for it, actually does work. We can find our way to the answer, and it really is the answer. It's not some kind of a trick on you. Should we do the last one here? I think we're on a roll. I think we have time for the number 13. Let's see, as x approaches infinity, this is different, right? Because otherwise it was approaching numbers. Now it's approaching a magic number that doesn't really exist, so we're going to definitely pay attention to that. Square root of x minus 9 over 2x minus 6. Okay, so let's ask a question here. When x is going to infinity, how much does infinity squared, which is bigger than the entire universe, matter compared to -9? I'm going to argue that it is infinitely unimportant that this is here. So on the top, I'm going to basically get x, the square root of x squared. And on the bottom, -6, infinity minus 6 doesn't mean jack. So I'm just going to write 2x. I'm going to cancel this. And you're going to find that the limit is 1/2. That is all about going to infinity for x's. It really does make things easier than the regular questions. I wish that we would have more real-life applications for that. So in the next video, we'll look at the other parts of the chapter review, but this is the finding limit example set.